Okay. Good day, moms and sir. This is Sir Ken once again. For today's video, we will discuss right now the topic about the dependent samples t-test using the SPSS. Now let's start. Once again, you have to open your SPSS here. A while ago, we are able to perform the independent samples t-test. Now this time, we are going to do the paired samples t-test. Okay. Now to do that, so go back once again to your variable view. And right now, I am going to encode the variable, let's say the English. I have here the question, by the way. Example, um, is there a significant difference in the English scores? No, this one. Is there a significant difference between the math scores and the English scores? Okay, so I have here already encoded the math score value, and I have to encode here the English scores. English scores. Okay, so I'm gonna leave, just remove the decimal here, and it's type of measure, it's a scale because it's a score. Now this time, you can see here another column was created right here, and I am going to copy now English scores. Okay, still it is under in the parametric test, because you could see here that we have 30 samples according to the central limit theorem, and we will check later on if this uh, falls still into a parametric test. So we're going to perform an assumption test which would validate and check if the idea of central limit theorem was actually satisfied. So, but generally, if you could see that the number of participants is 30, or above 30 and so on, or 16, you can perform the uh, the parametric test. Okay. Now, again, our question a while ago is that is there a significant difference between the math scores and English scores? Now, to do the perform the test, just click Analyze, Compare Means, and Paired Samples t-test. Okay. So here, you could see in this pop-up window, you can see here some the variables that we have encoded, the math scores, gender, and the English scores. Now, all you need to do is to transfer the math score in the variable 1 and the English scores into variable 2. It doesn't matter, mom, sincere, if you put here the English score and the math score here, so it doesn't matter. So, okay. All right, the math scores and English scores. And for options, I think there's no need for you to change everything. So just okay. And then let's try to check and click OK. All right, so you can see here some very important results. So you can see here the mean score of math is 27.40. So meaning to say, if we are going to add up and divide it into 30, the mean score the average score that we will get is 27.40. And if we're going to add up all the scores of the students, or of that 30 students, into divide it into 30, so we will get the average of 37.60. Okay, so if we are going to closely look at it, there seems to be a difference. Now, in order for us to check whether this difference is significant or not, we have to go here into this column. In this table. All you need to check is this value, the sig two-tailed value. Now, it shows here that the sig two-tailed, or the p-value, is 0.000, which is significant, okay? So meaning to say, the difference of these 27.40 and 37 is significant. So when reporting for the results of independent samples, is you just have to report or discuss the t-value and the sig value, or report this one, just only this t-value and sig value. You can also try to incorporate some reason why there is a significant difference. So because it's very obvious, the mean scores actually tells everything. Now, in performing these tests, there are some assumptions that we have to satisfy first before we are going to do this. If you're going to just simply adhere the essential limit theorem, as long as you do have like enough samples, so you can already perform it. Okay, but if you're going to really make sure everything, you can go back to its assumption and try to check whether if you violated any of the assumptions. So, but you know what, ma'am and sir, in reality, based also in my experience, the data is so robust, and we can't really avoid some violations in the assumption. So there are some instances you might tend to violate some, but it might also you will also yield some sort of variation, but it won't really matter. Okay, so but for good practice, for the benefit of this video, so I will be showing you on how to check or to assess the assumptions. The first assumption is, of course, the dependent variable should be measured on a continuous scale. Okay, so our dependent variable should be measured on continuous scale. So either it could be an interval or either it could be on a ratio level. So our scores are actually in the dependent I mean in the interval or in a continuous it's a continuous type of data. Okay. Another assumption that we have to make sure is that uh, both of these variables, both of these must actually consist of the category or match pair. It should be match pair. So, meaning to say, this can be from a one student only. The math score of the student one, and what is the math score of person number two. Uh, this paired samples t-test can be also used to assess if, like, what is the pre-test, the difference between the pre-test and post-test. Okay, the difference, what's the difference between before and after the intervention, kumbaga. Okay, so it is related because it indicates the same subject are actually present in both groups. So meaning to say, same student lang ang nakakuha sining scores. Okay, so both of the students did the English test, which he or she got a score, and also the same with the math. Okay. Now, the next assumption that we have to check is there should be no significant outliers. Now, to check if there is no significant outliers, you can do that by means of like here, uh, descriptive statistics. You have to click explore. Now, so you have to transfer here the math scores. So outliers and this one. Let's try to check. Also, transfer here English score, statistics, descriptives. That's okay. Plots, you just click the stem and leaf, and normality plots with tests, because that would also give us later on some interesting results. Options, no need to change everything, and just click OK. All right, so you could see here that our scores. Now, here in the normal QQ plot, you would see that this scores, these dots or hollow circles, represents the score of the students. So from uh, 20, 25, 30, 35, and so on. Now, you could see here that almost magkalapit-lapit ang scores. But if there is an outlier, you could see some scores here about like 35 or below than that. So that is already a violation, or that is what we call the outliers. Okay? Same thing here in the English scores. So QQ plat for English scores, magkalapit-lapit man siya gyapon. So there is no outliers. Again. Okay? All right. So that is how you can actually check if there is a an outlier or not. Okay? Now, so that those are the assumptions that we have to satisfy before conducting or doing the paired samples t-test. I hope you've learned something, and thank you so much.